Hello everyone! In this video, we will make a 240 volt plug adapter for our factory provided electric vehicle supply equipment. Later in the video, test if it doubles the charging power output from our factory supply device, charging in half the time. But first, a bit of how this came. In March of 2020, I acquired a Kona electric. For the US market, this EV comes with what is known as a granny charger or a trickle charger that operates at 120 volts 12 amps for a maximum power of 1.4 kilowatt hours. 2 weeks after getting the car, the pandemic hit and the car was seldom used. So this power supply was enough. In time, I drove the car more often, but still not enough that require a level 2 EVSE, and my charge was lasting about 18 days, from 80% to 20% state of charge. But it took about 30 hours to charge an 120 volt power outlet. Then I thought, a level 2 is 240 volts. Was there a way to use this at 240 volts without causing damage? I started to research this power supply and found an electric vehicle forum that stated that this charger could work on 240 volts, but the original poster did not provide any more information. Then online, I found the site EV Doctor where information about this confirmed that this particular EVSE or power supply was tested and could be used on 240 volts with the right adapter combination. So that's what we are going to do in this video. Let's get started. We will be using a Nema 615 plug that will be powered from a 240 volt 20 amp circuit. On the other end, it will be an American standard 120 volt or Nema 515 receptacle. As for the wire, we will use about 18 inches of 10-4 service cord. But this could have been made with 12-3 service cord and be within safe amperage rating as the power supply max setting is 12 amps continuously. For both plugs, I went with the professional series ends as they have a tighter grip and thicker contacts. To make the adapter is straightforward. We begin with the 615 plug. This connector has 2 bronze colored screws and 1 green screw, indicating 2 load lines and 1 ground. We measure for length and how much insulation needs to be removed. The downside of the 10-4 cord is the extra line and thickness, as we have no need for neutral. So it's a bit hard to work with. Therefore, the 12-3 wire recommendation. When removing insulation, be careful not to cut too deep or we could cut into the inner wire sleeve and expose copper where we don't need, and it becomes a safety issue. Here I'm separating each wire to cut the neutral and clean up the reinforcement cord that is in the wire. Neutral is not used, so we cut this wire as close as possible to the base. At the plug, there is a slit used to measure how much insulation of the wire needs to be pulled off. We cut about 10 millimeters or 3/8 of an inch from the wire's insulator to expose the copper. We will use the red and black wires for the two load lines, which will go into the two brown screws. Then, the green wire with the green screw. After making sure that all the screws are properly tightened, we tug the wires a little bit to make sure that none of the wires pull off from the connectors. We follow the same process for the 515 receptacle. The green wire is placed into the green screw for the ground. We install the black wire into the brown screw and the red wire on the silver screw, which is where normally the white wire goes. Ground is very important. The power supply will not initiate a charge when ground is not available, indicating a fault or a red indicator on the EVSE. Same behavior appears on 120 volts without ground or an incorrectly wired receptacle outlet. Since we have this combination wall outlet at this location, far from the workbench, we will use this to test the adapter. If everything is done correctly, there should be no circuit trip. First, we test the power by connecting at the nominal 120 volt wall socket to make sure the power supply turns on. Now, knowing that it does power up, we connect the adapter first to our power supply and then to the 240 volt wall receptacle. And as you can see, it powered on without issues, and it's ready to charge an EV in half the time. In the previous segment, we saw that it powered up. Now I, wanting to know, had this one question. Why did this work? Well, it is possible to connect many level 1 chargers to 240 volts even if they say 120 volts for several reasons. Many chargers have a 240 volt design, which is the wider use voltage that will work internationally and up to 250 volts. They just put a North American label and plug on the device. These devices have a switching power supply that works on a voltage range 100 to 255 volts. This is not unusual. Check the label on your cell phone or laptop charger and you'll see what I mean. This is mostly done to have a one-size-fits-all. During my research about the EVSE in general, I found that the internal power supply for the controller is mostly the same or similar architecture for a wide range of electric vehicle supply. Besides, most notable differences being mains plug type and connector type. For this power supply, I could confirm this by the last 2 digits of the manufacturer's part number. Another point seen before searching if this could work was the handle of the power equipment. It is rated for 250 volts, 16 amps. While not a trustworthy way of indicating support for 240 volts into the unit, it was a good reference. How will the car receive the 240 volts to the onboard charger with this adapter is as follows. The two upper pins will become line 1 and line 2 for 240 volts. When used without the adapter, it will be line 1 and neutral for 120 volts. This is a view of the internals that show why it works and the components inside of the unit. These images are from Mike's Electric Stuff webpage where he posted a teardown of his Kona power supply, showing the internal power supply of the EVSE rated from 100 volts to 277 volts that in turn power the electronics and other components that make this work on different voltages. Hope this has been helpful, interesting, or at least entertaining. If you enjoyed this video, leave a like and comment below. If you want to see more like this, stay tuned. Until next time.